situation where if these were our grades, our students' grades at the end of the semester, we have a third of the class who haven't achieved mastery. So clearly this is not an acceptable situation. Let's look at where we stand now after the third semester of lockdown teaching. The pandemic indeed forced us all to teach 100% online. We had no choice, but most of the lectures were delivered on Zoom synchronously. Most of the exercises were also delivered synchronously by TAs on Zoom, so more lecturing there. So in our contact time with our students, most of the students have actually been passively listening to lectures. That means, for the most part, we are not harnessing technology to make learning more efficient. We are not moving some or all of our lecture material online, and therefore we are not utilizing our contact time to enable students to engage in active learning. And that, of course, leads to passive students. And as we all know, passive students learn less. And when do we discover that they've learned less? Sure, at the final exam level, where we get this result. Okay, it's totally unacceptable. Bloom, as I'm sure everyone knows, introduced his taxonomy, which everyone is very, very familiar with. Most people are not familiar, though, with some of his other very useful work. For example, in a paper in '68, he talked about the 4 conditions necessary to achieve mastery. Well, first, we need to define what we mean by mastery. I guess most of us will be using learning objectives couched in outcome points of view. So let's say we know what we mean by mastery. But we need to ensure that our students are equipped with a systematic, well-organized instructional pedagogy, which is focused on their needs. We need to provide assistance to students when and where they experience difficulty, and we need to provide enough time for them to achieve this mastery. In another very useful publication from '84, Bloom defined what he called the 2 sigma problem, which is couched in terms of how instructional methods using given teacher-student ratios affect the summative achievement scores, final exams, if you will. So for a conventional lecture-based approach, you're going to see distributions like this. Very broad distribution, very large dispersion of grades, where if this is what we consider mastery, a high percentage of students not achieving this mastery. Now, what Bloom asserted, moving to what he called mastery learning, if you will, active learning, with the same teacher-student ratio of 1 to 30, you can achieve much better results, a much lower failure rate, more students getting to mastery. Well, obviously, if we take this to the limit and go all the way to tutorial-based learning, that is 1-to-1, you get even better results. You can get arbitrarily very, very good results. However, 1-to-1 teacher-student ratio is not exactly sustainable, but mastery learning, which requires the same teacher-student ratio, is indeed sustainable. This is the way to go forward. Now, let me describe to you a working class-tested flipped classroom approach, which I say is working both face-to-face and, from my experience in the last 3 semesters, works very well even on Zoom, totally online. It starts with an online lecture, which the students have to prepare in advance. They watch the lecture material in advance of the class meetings. They proceed through this material at their own pace, and the clips are interspersed with activities they have to do also in preparation. The lecturer has the advantage of being able to, of course, observe all this in advance of the class meeting. The types of activities could be regular quizzes. They could be what I call your turn sandwich, meaning you provide a definition of a problem in one video clip. You require the student to complete the task on his own, and then the subsequent clip gives the student a sample answer. The student will then realize his answer possibly being different, will realize that in most unusual, realistic questions, there is usually more than one answer. And this is actually a good thing for them to learn and material for discussion when they eventually come to class. You can ask them to prepare for brainstorming. And all this in advance. The next thing is they come to a class meeting. The teacher can wrap up and close issues which he's observed to be problematic because he already saw what they did at home. Most of the time in class, though, is involved in student active activities. They solve open-ended problems, the kind of stuff that I found that works here. You quiz the students in comprehension, possibly revisiting quizzes that were done by them at home, but mostly to generate class discussion in class. And of course, mostly for open-ended problem solving. They actually do that with the lecturer in class. And what I'm doing in my classes is in this meeting, solving with them exam level questions essentially in my first meeting with the students. Subsequently, they come to an active tutorial where they actually come to grips with problem solving on their own. This is the most important feature of the approach, and actually gives the students a chance to do all this work with assistance by the staff. I say, and I discovered what agile teaching was only because Constance invited me to give this talk. Basically, the four main tenets of agile teaching involve the following features. First, your teaching has to be student-centered, focusing on the learner rather than focusing on the teacher. The class time is therefore used mostly to work problems, for cooperative problem solving, and for project work. It's reserved for collaborative work between the staff, students, and students themselves. The lecturer now is not a purveyor of information. He is a mentor and a motivator. That's his real task in the classroom. And of course, we now have time to respond to feedback of the students and to meet their needs. So basically what I'm saying is flipping is agile teaching. So sounds good in practice, but is it really worth it? That's the point. Because to do this, you need to make a sizable investment in time. You have to prepare all this online material. That takes time. Is it worth it? Let's look at it from the point of view of the students. If you poll students, and we've done this in every course I've taught now, this is going to be coming up to the 7th year now. You ask the students at which stage of the flipping approach did they actually learn the most? Where was their confidence in their mastery the most? And here on a scale of 1 to 5, 1 meaning absolutely no confidence at all, 5 being great confidence, this would be a typical result from polling a class after, what they see, how they feel about their absorbed knowledge after the online lesson. We're pretty much in the middle of the range here, but at every stage of the learning process, their confidence increases. After the class meeting, it's above 3. After the active tutorial, it's almost 4. What's also interesting, we take that last distribution, and analyze it separately for the students who are passive and the students who are active. And again, from observing their online activity and looking at their attention of the other sessions that we have, it's easy to separate. And if you actually do this analysis separately for the passive students in the flipping approach against the active, there is a significant difference between them, significantly different. So what you can say is, not only do the students think they learn the most from active tutorials, they learn even more if they're themselves active. That's a good message to carry on. So from the point of view of the students, it appears that this is quite an effective method. But, bottom line, what about outcomes? Okay, I've been teaching design using flipping now for 6 years. As I said, next semester will be the 7th year. And what I was getting before I started any active activity in class were distributions like the one I showed you before. A third of the class haven't really achieved mastery, and that's not a good result from my point of view. What I'm getting these days is something that looks like this. Sure, there are still clearly two populations in the class, but the weaker population is much better off than they used to be before, and that's a main achievement of this. And of course, if you actually look at the actual final exam, this is an actual result from last semester. Okay, so it's actually a pretty neat result from the point of view of the technical. No problem with this result. We've got 70% average here, and most of the students passed it very well. Again, if you divide this class into the active and the passive students, the difference is quite significant. I mean, the ones who actually partake of the opportunities afforded by flipping do much better than those who don't. And this is, on the Z factor of 4.51, that's highly significant difference. And the main reason for this is, of course, that if you look at the least attentive students, none of them managed more than 80% in the exam. So that explains this huge difference. So just to summarize what I've said, a very famous educator in chemical engineering, which some of you may know as Richard Felder, he talking about active learning methods, he said, "We never said it would be easy." And to paraphrase another famous person, what my West said was, I never said it would be easy, I only said it would be worth it. And like my West, I would say that going to active methods It does involve significant effort from the point of view of the teacher, but it leads to very, very good results. So I highly recommend as many people as possible move to these types of teaching methods. And we'll hear some more during the rest of this session. So that's me. Thank you very much for listening. I'll turn off my sharing now.
Thank you very much, Daniel, for the nice talk and also for keeping the timing. It will help us, during the Q&A session. So I don't want to hammer this. So I'm moving directly to the second lecturer, to the next invited speaker, Professor Nuno Escudeiro, who is going to present us a teaching model that we are trying to apply in the Athena European University, which is a very big initiative in Europe regarding higher education. Nuno is like a professor in the School of Engineering in Institute of Politécnico do Porto in Portugal. So the floor is yours, Nuno, for the next 15 minutes. Thank you.
Thank you very much, Costa. So I'll try to keep the pace and keep you such an interesting presentation as the one before. So I would like to talk to you about an initiative that we are running at the Polytechnic of Porto, and in fact at the Athena European University from this year, on a type of teaching paradigm that promotes student soft skills and their employability. Well, I will try to flip the classroom, or doing this the other way around as I usually do. So I will start to tell you where we stand, and then we will go down and see how we get here and what are the main findings that we have reached for the 12 years that we are running now. So what we have currently is a project course where the students get together in international teams from different study fields. So we have multidisciplinary international study teams that come together for a meeting that lasts 5 working days, where the students meet the company that are proposing a challenge for these teams of students. So the students have to organize themselves according to their competencies, and they have a kind of a budget, an ECTS budget that states how many CTS they have for each of the study fields, for each of the competencies that are required to solve the challenge to the company. And they have to propose a solution fitting this budget to the company. During the week, they work on this, they work on their own organization, and then they move to their own institutions where they will work during the full semester, except for the last week, developing their share of the project, but being always in contact. So using IT tools and also in this way, experiencing and improving their IT competencies. And this team of students, we give them the autonomy to generate. So each student has a supervisor. The supervisor is in the backstage, always available if there are issues to fix, but the students have the floor and the students have take the lead. So the students have to organize this team. Usually we get teams of around 8 to 10 students for each challenge. And they have to manage themselves, the tools to communicate, and all the development and all the meetings they do during the semester. At the end of the semester, they get together again for another week. And at this last meeting, they have to finalize the pitch they have to do to the company, usually on Thursday that week. And then they present the product they have developed to the company and to the teachers. They get evaluated and they give us feedback on how the course went. So this is the model that we are running. We have a big team this year, thanks to Athena. We have the biggest team that we ever had, 16 universities, 32 students that just concluded the course 2 weeks ago, with very good results from what we have observed. But we are running this, as I told you before, for 12 years now. So we have involved already nearly 50 institutions between companies and universities in many different regions, mainly from Europe, but also outside Europe. Getting here was a process that was motivated. We started discussing this in 2008, finding a way or finding ways to improve students' employability, to improve students' soft skills and the needs, and trying to bridge the gap between what the students learn at university and what the company wants them to have. So somehow assure that we have a smooth transition from education to labor. There are many studies that are supporting these motivations from the Commission, as well as from many other players. And we got to this objective. So we need to find some solution where we can promote students' employability, but without requiring any curricular changes. We don't want to go through a process that we have to change the curricula, go for ministry authorizations and all of that. So we want a model that can be adopted by any university willing to put this in place without these needs, and still develop student competencies through international cooperation and through project internship work. And this is mainly directed to a type of course where we believe this can be effective. So it's very common that our students in the last semester have a project internship course, and this is probably the best fit for this paradigm, because we can easily accommodate this to a capstone project without the need to change the curricula. So the target group is final year undergraduate students or master students that are also coming into the team. This process is running for these 12 years. So we started only with IT and with academic projects, and then 2 years after, we started having multidisciplinary teams. We start having real client companies to offer the challenges to the students instead of academic projects. And we had partners from outside Europe for the first time in 2015. We have identified a very interesting niche for this type of initiative, which is the niche of the startups and the incubators that have, where we can easily find challenges for the students to develop a proof of concept. And this is very beneficial also for the company. So this is a win-win situation. The companies that have a need, that want to essay a new product, a new methodology, a new process, they can have a team of students mastering the competencies that are required together with the supervisor teachers, developing this in a short period of time, which is critical for the company. So we can give this proof of concept in 4 months, which is completely different from going to a company and say, okay, let's cooperate with us, and within 2 or 3 years, you will have some results. We can tell this to the companies, but in a short period of time. And this is proving to be very effective, mainly in this niche of the startups. And now we have another hallmark, which is the Athena European University, and also very important, the new Erasmus Plus program, which is a program that is much more, where we have much more opportunities for blended mobility than we had in the past. So along this path, all these milestones, all these hallmarks have appeared in a natural way. We are moving and things were happening, and we are understanding how we could improve it. And it's interesting to know that more or less every other year, more or less, we have a very important step forward to reach to the moment where we are now. So let me very briefly now give you an understanding of the main findings that we have collected from this year. So we are motivated by mainly these 2 observations, that project internship are academic activities that foster students' employability, and that the international exposure during the studies, when our students are 21, 22 years, it's very impactful to their development, both as professionals and also as persons and European citizens. So having these motivations, we have identified that there are many barriers to mobility, mainly to international mobility. So there are many students that are facing these barriers and that they cannot do and benefit from this international exposure. And this is really a problem that we would like to fix. Blended mobility is in fact overcoming all of these barriers. So the approach that we are using is a very interesting solution to solve and to fix these problems. In particular, we have many students, mainly master students, that are working and studying in the evening. And for these students, it would be impossible to quit the job for 4 months and have this experience. And they can do this in this type of teaching environment. And it's also very important, which was also a surprise for us, to know that this is also sustainable education. It's green education. We did a study 2 or 3 years ago, and we have asked former Erasmus students, so Erasmus that had gone on an Erasmus mobility, how many times do you travel back home during your internship or during your mobility? And we did this also with we analyzed this also with our students. So what we got is that a standard Erasmus mobility, during a standard Erasmus mobility, students travel back home 2.5 on average, while our students do this 1.8 times on average. Well, this depends on the size of the team, because the meetings that the students do face-to-face are always on a partner university. So the students from the partner university that is hosting the meeting do not have to travel. But anyway, we have a gain, and we can reduce the carbon footprint approximately 30% compared to traditional Erasmus mobility. So reaching to this point, and I think we can now stress the main reasons why we are fighting with this for the last 12 years and very eager to continue. In fact, we are already organizing a meeting in early September to start discussing the next edition of the course. And I believe these are the main reasons why we are still working on this and very enthusiastic with it. This is really a unique learning setting to promote equal opportunities to our students. This is really democratic education, because no matter what are the barriers the students are facing, they can benefit from this international mobility, because they will not be forced to be a big period far apart abroad. And this is a way to tear down all the barriers to mobility, or most of the barriers to mobility. This is an eco-friendly approach, and very important, it is easily adjustable and adopted by any degree, because it does not require any curricular changes. It is also a very resilient approach, as we have seen for the last 2 years. I will get back to this right after this brief introduction to the course. So the course is organized in these 3 steps, and you can see here the physical parts and the virtual parts, and this is what makes this the blend of this approach. I'm not going into details. You will have access to this PowerPoint, so you can take a look at the details if you want to implement this on your own, but I would like to stress what happened these last 2 years. So in 2019, 2020, we had the kickoff meeting in February in Ghent. It was face-to-face. It was, in fact, the last trip I did before the lockdown. And we had all the students together. But then immediately after that, the COVID lockdown arose, and we had to do all the rest of the course online. But what is important to stress here is that our students concluded their course, while most, not to say 100% of all the other students that were doing their Erasmus mobility at ESEP, at IPP, had to cancel that in the middle of the process and come back because of the COVID. So this, in fact, is also overcoming this type of barriers. This year, we did it almost fully online, except for the last meeting where we had some of the universities that are in the same country putting the students together, and those that are farther apart doing online. So how can we start to do this? Well, you can join us, you can join, and this is a very standard way to do this. So the university that is willing to come joins us for one of the meetings, feels how the vibe and how it works, and then they join the next year with a team of 2 students, 1 teacher, and they are engaged on this. Or you can do it yourself. So you can get together a group of universities that you think might be interesting in this, and then in this case, just feel free to use the outcomes and all the products, all the developments that we have already on this. We'll be very happy to support you developing this. The aim that we have, the big ambition, is not to have 16 universities, but we have 60 universities, so that we have a pool of universities and the companies can offer challenges, so that the students create the teams without knowing who their teammates will be. They will just apply to the challenge. They believe it's more interesting for them, and then we will create the teams from these applications, joining together the competencies that are required to do this. We have the tools to take this further. we have the team, and we would be very interested to have more universities on the team. So you'll be very much welcome if you want to join us. And here we have a list of resources that you can use. Thank you very much.
Excellent, excellent timing. Thank you very much for this very exciting projects that you are very persistent. You know, the last 12 years, as the first speaker spoke to us, we should do things that they are not easy, but things that, you know, they deserve our efforts and our consistency. So I'm moving to the third speaker right now. So thank you very much, obrigado, Nuno. And if you have any questions, there is going to be a questions and Q&A session at the end of the talk. And I can see now that Ron Blonder, Professor Ron Blonder, is ready to start her talk on how do they apply virtual educational escape rooms for chemistry students. Ron Blonder is a professor in Weizmann Institute of Science and is on the Department of Teaching Science. He's a very experienced and very distinguished scientist on what she's doing. So it's a great honor to have with you, Ron. The floor is yours.
Thank you, Kostas, and hello, everyone. As we heard in the two previous lectures, agile teaching is something we must adapt, and I think the COVID really had the great power to convince us that we should be flexible and we should be able to put the focus on the students while they learn, to provide them opportunity to solve problems, collaborate. And in this talk, I'm going to present you a development effort that was done in my group by this team, the escape room development team. And the way we implemented new design principles in order to take a physically escape room and to move it towards the virtual space. So let's start. I will shortly start with the explanation of what is an escape room. I guess most of you know what is an escape room. It's a game. It's a genre of a game. And usually 4 to 6 people have 1 hour to escape a room. They have to solve the quiz and the puzzles, to do some activities in order to get out of a locked room. Okay. In the Weizmann Institute of Science, we have developed educational escape rooms. In this case, we need to take this genre of escape room and to adapt it to a classroom, to a full classroom of students, but to keep the engagement of the escape room, although it is done in school. So if we conduct an escape room in a laboratory, or chemistry laboratory, we must keep the safety regulation. We must use available materials that are not expensible. We should connect the escape room to the chemistry curriculum that students learn in order to be meaningful for chemistry classrooms and in order to be helpful for the teachers that want to teach chemistry. We should think about ideas how to adapt this escape room genre to big groups, to full classroom of students. So you see, we have a lot of challenges. We also have to make the escape room to be mobile, because teachers can take these mobile materials and components of the escape room and build it in their own school laboratory where the students will experience the escape room. So what can we do? We also, in the previous version of the escape room, we used a chemistry experiment. We called it wet puzzles, in which a student conduct an experiment and the experiment solve a puzzle. For example, here they inject the acid to a purple solution. It turns out to be transparent, and they see the number that opened a lock, for example. And also dry puzzles in which they have to implement knowledge in chemistry to solve the puzzle. So why to do it? You see, it's a lot of effort. If you experienced an escape room, you know it is really fun. And we want to take this fun feeling to the formal chemistry education. When the student participate in escape room activity, it increases their motivation to learn chemistry. It shows them that chemistry is usable. It requires skills such as teamwork, problem solving, and we realize that these skills are really important. They are part of the 21st century skills that we want to develop in our students. And usually when they sit and learn in the classroom, they are passive and they don't develop such skills. The escape room shows them the science and the engineering subject in a different light. It's not just hard subject matter that they should learn. It has other aspects. And it uses multiple intelligences, namely it's not just the mathematical logical intelligence, but they have to create and to think and to build, so they can express other dimensions in their abilities. Usually, we use the escape room as a summary. We teach a subject, the teacher teaches a subject in chemistry, and then she brings the escape room to summarize the topic. But students can also find this activity as a formative assessment, because during the activity, they are able to realize what they better understand, what they master, what they still don't master, and they can further study it. So all these good things were stopped because during the COVID, we couldn't continue to perform these escape rooms. Teachers couldn't come and take the kits and build the escape room in their classes because students stayed at home and were not able to meet. So the ability to maintain the escape room activity was stopped. And we decided to think how to take this very good activity that has all these advantages that I described before, how to take it to the virtual space. And first, we thought about an escape room that was already developed by our team. The escape room about the periodic table of the elements. And we thought, okay, we have this escape room, let's take it and transfer it to the digital space. But fast enough, we realized that we will not be able, if we will transfer the original activity that was done face-to-face to the digital space, we will lose a lot of the good component of the escape room. So we decided, instead of transfer, to do a transformation and to use new design principles that maintain the good quality and the good things that they can benefit from the escape room. Okay, so I want to show the design principles first. Before we use school lab experiments that the student conduct, here in the digital space, we can use things that we can never do in school. For example, explosions or radioactive reactions. This cannot be done in school laboratory. We decided to include activities that cannot be performed in real life. For example, to fix the iPhone screen. One part of the activity, the iPhone of the player is broken, and the student should choose the elements from the periodic table to fix the screen. In real life, I'm not able to fix my screen. I have to take my phone to a professional place. But in the digital place, we can do whatever we want. And also, another thing that we do in this escape room, that digital opportunities, is actually to change and correct an historical injustice. So I want to, in addition to this design principle, the development team also had to rephrase new guidance and rules that are more suitable for the digital space. For example, if in the first we had to start the escape room with lab hazards and behavior, here we had to talk about technical instruction. For example, the student with a fast internet should share the screen, or the student should talk aloud describing what she does in order to enable the other students in the group to be involved. In the real escape room, in physical escape room, the student ran in the class and looked for clues, collected the items. Here they collect items in the virtual space to solving puzzles. Also here, collaboration is essential and there is no competition between the groups. Each group work in a separate room in the Zoom. So I want to shortly, I don't have time to shortly present one or two puzzles from the virtual escape room that is called The Masked Scientist. And this is a virtual escape room about the periodic table of the elements. And let's see. For example, do you remember I told that we can do experiment with materials we are not able to handle in school laboratory? For example, radioactive decays. This is a smoke detector, but the student need to naturalize it in order to pass a corridor. So in order to naturalize a smoke detector, there is a radioactive reaction, and the alpha particles that are created in this decay emit molecules of oxygen and nitrogen in the air and ionize them. And the electrons and these ions create that are created in the collisions are close a circle, and there is a current. And where we have smoke, this current is decreased. And this is the way smoke detector works. So first they naturalize the smoke detector. Then they have to pass these two, do you see these two lasers that create laser beams in the corridor, and they have to pass it in order to reach the door. So how can we create here smoke? They have several components, several things they can use. They have gas mask, they have water, they have the map, and they have this compound. Let's see. The compound is a nitrogen triiodide. And if they balance correctly this equation, they realize, you see, balance me, they realize that the nitrogen is created. And actually this compound is very, very exposable. Let's see, this should work. Do you see it now?
When nitrogen triiodide, the dark colored solid, is dry, it is very sensitive to touch or any vibration. Simply touching it with
We can't see
it.
Okay, see.
When nitrogen triiodide, the dark-colored solid, is dry, it is very sensitive to touch or any vibration. Simply touching it with a feather causes it to explode or detonate.
Okay.
One detonation causes another to occur.
So, just a second.
When
Let's go back to nitrogen triiodide. So we conducted an explosion. So just imagine this compound in school laboratory. It's dangerous and we will never have the ability to work with it. You see down below, we see this compound after the explosion, and we have this iodine gas that enables the student to see the laser beam and then to pass the corridor. And at the end, I don't show you all the puzzles, but at the end, they are able also to correct an historical injustice. One of the scientists really was that she's I'm spoiling the escape room, but I don't think you will be able to do it. But at the end of one of, as you see, Rosalind Franklin, she is a woman and she was Jewish in a wrong time in the history, so she didn't receive the respect and the recognition she had to to receive based on her scientific work. And later on, this injustice was corrected, and one of the elements in the periodic table was called after her. The meitanium atomic number 109 is called after Rosalind Frank. I'm sorry, Liza Meitner, and this injustice was corrected. Let's see a little bit what students said after this experience. She realized what skills she still needs to master after this experience. And this, she said, okay, I worked with and collaborate with the people I'm less familiar with. Just remember, these students didn't meet each other during the COVID in face-to-face. And she realized, okay, we used our chemistry knowledge to solve puzzles. And this guy said, okay, this broke the Zoom routine. It is something special. I have to finish, but I want to thank you for your attention and to thank again the development team that took part in this development of the escape room. Thank you.
Thank you very much, Ron, for keeping the time and for the nice presentation. And let's move to the last one, to the last presentation from Mr. Lourakis, Manolis Lourakis from the Hellenic Mediterranean University, who is a PhD candidate, and he's going to present us how did we apply SCRUM along within the framework of Agile education. SCRUM is a key, let's say, way of training the team to work as a team. So Manolis, the floor is yours, and you can share your screen whenever you want. Manolis has a bachelor degree in electronic engineering. He's an ex-aviator in F-16s, so he has a very mature background, and this, I hope, that reflects his work. So the floor is yours, Manolis. Thank you.
Thank you very much, Kostas. I believe that everybody hears me well. This is the outline of my talk. We are going to see a little bit about SCRUM to get everybody familiar with this framework. We were going to see how did we apply this in the last semester, the tool we used, the results we expected to have, the feedback from the student, and what is our next step. SCRUM is a framework. It's not a methodology. It helps people to work together and to be more efficient. The main concept under SCRUM is that it takes the work to be done, divides it in the smaller steps, smaller actions, and during constant iterations, the work is done at a period of time. And also the work by itself, the whole work is divided in periods of times, which they are called the sprints, and the teams work together and they meet in daily basis. That's the key concept of the SCRUM, which of course SCRUM comes from the Agile Manifesto to make the teams more involved and self-learning. So the players of SCRUM is the product owner who has the responsibility of the final outcome. In our case, it was Professor Petridis that he teaches the lectures of Physics 2, where we applied SCRUM in the last semester. Scrum Master is a kind of supervisor for the teams, for the developers. And that was my role during the last semester and in this experiment. And also we have the developers, that is the teams that they're working towards the final product, the outcome. The final product for us was knowledge in a different way, self-organized by the groups itself. The intriguing part on the Scrum is that what you see here on the blue box, there is no leader in the teams. The teams are self-managed, they are kept small in size, and there is no hierarchy. So everybody has to work with everybody in order for the team to succeed. In order for a procedure to qualify as Scrum, has to obey these 4 events that they are in bullet number 2. Initially, the procedure starts with a sprint planning, which is usually a long in duration in real life. But here in the higher education, as we applied, we shortened a little bit, because what happens in this initial meeting is that the product owner, along with the stakeholders are the ones that pay for the product. They are paying for the research. They present what needs to be done, what is the demand, what is the need. So in this initial meeting, they brainstorm and they conduct a list of steps or action that the teams must take in order to fulfill the task, to produce the product. This complete list of steps or actions or things to be done, it is called the product backlog, and it is one of the 3 artifacts of this framework. Also in this planning, they decide how much time do they have, and also they assign the sprints, the working periods, at the end of which period they have to, the teams have to introduce what they have done during this working period. The working period is called a sprint, and after each sprint, the team presents its work in a meeting called sprint review. Again, in the sprint review, everybody participates, the product owner, the Scrum Master, the teams, and the stakeholders, because Scrum adheres to 3 pillars, which are transparency, inspection, adaptation. And in order to be able to minimize risk and to make the work more efficient, everybody must be present in this sprint review after each sprint in order to find out if something is going wrong or if something is going okay, so they will keep their work as it is. And after this meeting, a very key meeting is with the team itself and with the Scrum Master, not the other guys, where they retrospect what they have done correctly during the last sprint or what they have done wrongly during the last sprint in order to improve for the next sprint. Also, in this sprint, they retrospect, in this meeting, they retrospect the tools they use to find out if there is any need of changing the tools or using new ones. So what is produced during this procedure, this framework, they are called the artifacts. We have the product backlog, which is everything that needs to be done in order to have the deliverable product. We have the sprint backlog, which is a smaller subset of the product backlog. Sprint backlog is the items that need to be done in each sprint. And each day, the team must provide a document of their progress. And this is done using bear-down charts. These charts document the progress of the team, so they keep track about the timeline and how much time do they have to complete the work. So Scrum in a glance, we have the initial meeting where the product backlog is comprised with collaboration. Then the teams go to work. Each team picks a subset of the items from the product backlog. So each team makes its own sprint backlog and they start working. They have the authority to add tasks or items, but they don't have the authority to remove any items from the original sprint backlog. And they work for 30 days. That's the maximum sprint period according to the Scrum official guide, which is available online, free of charge. And the team meets every day during a stand-up meeting, maximum 15 minutes in duration with the Scrum Master. This is called the daily Scrum or stand-up meeting, where Scrum Master poses 3 questions to each member of the team in order to find out any difficulties or with the task to alleviate any problems. The 3 questions are individually to each member: what did you do the last working day? What are you going to do the next working day? And did you face any problems? So let's see how did we apply all this in a remote teaching environment, which was a great challenge for us. The challenges were that we have never applied this method before, and we had to apply it in a remote teaching environment due to COVID-19 restrictions. The other challenge is that this has to be done. This experience came on top of all the other students' obligation. We knew from the beginning that it's going to be hard for the students. The desired outcome was to learn by their own, adhering to the principles of Agile Manifesto, working in groups while attending the course like the rest of the students. And the other axis of our effort was to enhance their soft skills, communication, keeping deadlines, work in teams, etc., etc. The selection of the teams were completely by volunteers. Initially, by a raise of hand, we had 20 volunteers. At the final stage of initiating the project, 10 people decided to participate. We had students from different semesters, and we decided from the beginning of the semester to do 2 Scrum projects. The first Scrum project from the beginning of the semester until just before the Orthodox Easter, early May. It was done by 3 teams, 3, and 4 students accordingly. And the second Scrum was only by 2 teams, 4 and 5 students. It was the same students divided differently. So the sprint assignment and duration was, for the first Scrum, 3 sprints of 14 days each. For the second Scrum, only 1 sprint, 3 weeks duration in total. The final product, what we asked from the students to deliver to us, was 1 45-minute presentation explaining the function of the electronic or electrical device, but using concept, laws, and terms from the Physics 2 course, not popular science. Also, what other thing we asked the students to produce was a 30-minute presentation for the sprint review after each sprint. So we also had a 30-minute presentation explaining how did they learn, what did they learn from the backlog items during the last sprint. And also it was a demand every day to provide a bear-down chart in the standard meeting, which was showing the progress of their work. One thing we decided to do, and it proved helpful, is that the initial phase in the sprint planning meeting, we provided the students with a ready-made backlog, because the product owner, Professor Petridis, had a course to teach. So you can see here the Scrum 1 product backlog. It's everything about Physics 2, and it's the beginning of the lectures. It's the material of the lecture he was teaching at this semester. So team 1, at the end of the 3 sprints, had to explain the function of the rectifier diode, the other team, the MOSFET transistor, and the last team, the function of the Faraday cage. But in their presentation, all these items should be evident. For the second Scrum, it was smaller product backlog, lesser items, but with more harder concepts and meanings in physics. And for comparison reasons, we decided both teams to have the same final product to explain the function of the AC generator. So the tools we used, the students decided by their own all the tools, by conferring with us. So for the virtual space, for meetings, exchanging ideas, exchanging materials, and talking to each other in groups or collectively, we use Discord. It's an open source application, publicly available for Android and OS devices, Apple devices. For the meetings, sprint planning, sprint review, and sprint retrospect, we usually use Zoom platform. For the delivery of the product, the presentation of their work, they prefer PowerPoint because the majority of the students were already familiar with that. And for the bear down chart, which is in the vertical column is the effort in hours, and in the horizontal axis is the dates, the days of the week they have. They prefer to use Microsoft Excel, again, because they were already familiar of this tool. So what were the results we had? All teams managed to deliver the products on both Scrums, and this was very promising for us, and very, very positive results from our side. Total artifacts we gathered 6 presentations, 30 minutes each, 5 presentations, 45 minutes each, and 56 bear down charts. Because we allowed the teams to work in their own pace, each team worked differently. So the average working work days was about 4 days per week, with a duration of 2 hours per working day. We had only one dropout. One student couldn't make it, couldn't handle the pressure, so he dropped out at the end of sprint 3 on the first Scrum. We collected the feedback from the students using a Google Form questionnaire. The attending semester, the majority was in the second semester. The 22% was for fourth semester, 11% eighth semester, 11% again from sixth semester. The majority of the students had participated in the past in group assignments, and the size of the group was almost pretty much the same we used in the Scrum, 3 to 5 people, the majority, and some people have worked in groups of 1 to 2 people. The funny thing is that some people had heard of the Scrum before, the majority they didn't. That's why we provided them with 2 lectures at the beginning of the process in order to understand what they have to do and to make their final decision if they are gonna take part in this venture. So the positive thing is that at the end of the Scrum, the majority of the students answered that it was neither difficult nor easy. It was as expected. That means we succeeded at guiding them in this process. And this answer here is very promising. The majority of the students, almost all, believe that they took more knowledge using this Scrum framework in group assignment than just attending the class. So following the last question, and this is very promising for the Scrum framework, almost all of the students thought that Scrum framework helped them conduct the teamwork better. The last one, the second axis of our effort, was to enhance their soft skills. And here you see some standard abilities they think that they got better. So our future work, what comes next for this framework Scrum for the next semester, and we hope it's going to be face-to-face. We would like to applicate the Scrum project with bigger teams. We would like to stress up to the maximum of 10 people. We are thinking of changing the final product to a manufacturing of a simple device, electronic or electric. We would like to assign the Scrum Master role to the students. It will enhance their leadership. And also we would like to train faculty on this framework. That concludes my talk. Thank you very much.
Thank you very much for the presentation, Manolis, and keeping the time. So we are open now for questions. I have already talked with the organizers that we are going to have these 10 minutes for questioning time, or if we need more, if there are more questions, I hope that they will provide us the extra time that caused by the delay at the beginning. So the floor is yours for questions. You can type your questions to the chat, or you can switch on your microphone and ask the questions directly to the speaker. If not, I have my questions, and I will start in order to warm up the environment. I would like to, my first question comes to Daniel. So I will follow, the ordering. So Daniel, very nice. I can see, 3 hours online lectures, 2 hours of class meetings, 3 hours of active assessment. This makes, only regarding this kind of engagement, the workload of the students, which is not the only one, 6-8 hours. And I would like to ask you, if the students in Technion, even though that you have fantastic results, each one of these course, has this kind of workload, how do they reflect the students? And what is the support that you are receiving, despite of your nice results from your institutions, to make this the pedagogy and the teaching model of everything in Technion?
Thanks for the question, Kostas. First of all, there is no increase in load. It's an optical illusion. Students, to learn, they have to do homework. So if you compare the initial setup, where you'd have typically 3 hours of lectures, 2 hours of exercise, there would be homework time associated with that. Now, all we've done, let's say 3 hours of homework for 3-hour lectures would be reasonable, the same 8 hours. All we've done is we've switched the role of the homework to be watching the lecture, and the homework, what used to be homework, is what they do in the active tutorial. So actually, there is no difference in load from the student's point of view, assuming that we count the homework, which, to be fair, you should. They won't learn anything otherwise. What is different is that when we have these active tutorials, we really require a higher number of staff to be present to provide support. What I've been given up until now is additional help for that. You need more people. And as a measure of my own commitment, I add myself as another assistant. I am present in the active tutorial to help out. The load is different. The load is actually on the staff, much more on the students. Now, the students' opinion is, of course, it's much more work. Why? Because they don't think about the homework as being load, which means basically they're not all doing their homework, right? Now, without actually doing some work, a student will not learn anything. That's what I'm saying. Did I answer your question?
You answered my question, but now what about the academics? I mean, if they load, if you increase their load, how your pedagogy can be followed by me? If I was in Technion and I have my research, I have my teaching, I would like to do my teaching better, but I should correspond it, I should budget my time.
Absolutely. So what I would recommend anyone who tries this, start small, aim small, start small, start with 1 week of activity, try that. I guarantee that if you do it right, you will be so impressed about the difference, that will give you motivation to do it more. And you don't have to transform your course overnight in one bang. When I started flipping, I did 1 week. That was enough to convince me that it's worth doing, right? Now, does that mean that the entire technique is flipping to flipping? No, but what is very encouraging is that many are. Even to my big surprise, the mathematics department, that was my biggest, very pleasant surprise, that I'm hearing of a lot of maths teachers who are actually going this way, and they're all reporting how much they enjoy the switch. So start small, Kostas. Have you actually started flipping yet? I'm pushing all the...
I'm doing it.
See?
Starting small.
Okay, cool.
Okay, thank you very much, Daniel, for the question. The next question comes to the second speaker, to Nuno. So Nuno, excellent. I can see that your approach is like more related to project-based learning approach. But I would like to ask you, who is funding the students' projects? Because if we are talking about constructions, there are some consumables, some money to be spent. So who is budgeting, this kind of projects? And if you have received any feedback from the students regarding their employability, because they work for, the companies, they check, their skills. Do we have any positive reflection regarding directly employed the students to the companies?
Yeah, thank you very much. So regarding the budget for these 12 years, we have been supported by Erasmus Plus projects on 5 years. So we have applied for the first time for 2 years. Then after 3 or 4 years, we applied again and we get this support. For the other 7 years, each university is finding its own funds to support the travel and for the teachers and the students. And for the last 5 years, we have been getting also some support from the companies that we are developing the challenges for them. So companies are mostly supporting students' accommodation for the meetings, and the travel is being supported by the universities. So this is what we have been doing so far.
So regarding the consumables, these are coming from students' budget.
The consumables, what do you mean?
I mean, if they are going to build, an electronic system, someone should buy,
in that case, that happened already 1 or 2 years with Arduino and all that. So the companies are giving the resources that are required, either hardware or software. So we try to avoid, so students do not have costs, so we get the money for the daily allowance from the universities, and the other part from the companies. The other question you asked, sorry,
was the impact of collaborating with the companies for their employability.
Yes, so we have very good feedback from the students. In fact, we have published a book that is available in Amazon, but I can give you the chapters that one of the chapters in this book was written by the students, and we have very good feedback from them, from the experience they got. In fact, in Ghent, we knew that one student went after the first 6 or 7 years, one student went to a company for a job interview, and the company asked them, have you done this course? Because this company had already employed students that have done the course, and they were asking explicitly for that, have you done this course? So the impact is good when it reaches to the other side. It's really good.
Thank you. So we are open for these micro credentials type of
Yeah.
short diplomas.
Okay.
Thank you.
Yeah.
Thank you very much, Nuno, for the answer. And now I'm moving to Professor Blonder, to Ron. Always I'm jealous of chemistry because what I can see everything like chemistry. And, you know, I say like, when I was in physics department, I said like, chemistry, okay. It's like, you know, physics is not something. So why all these nice things they are applied for chemistry? Like, or it's like a coincidence. For example, escape rooms in chemistry. What about, you know, if I would like to apply the escape rooms, you know, in physics, is it possible? And my second question to you, Ron, is the following. How easy I can integrate this tool within an existing course? So I would like to use, you know, all these techniques, starting from Daniel, following Manoli's instructions and then following you in physics too. I would like to make physics too, you know, that course in my school. So in a good or in a bad manner.
I'll start with the first question. And if you can see with us, Dr. Malka Yayon, she leads the escape room effort in the group. And I think the escape room are not only for chemistry, but in chemistry, we have these creative people like Malka that can create the escape rooms, you see? So you need to find creative people in order to have creative results in teaching. But in general, you can read in the literature, escape rooms are employed also in other areas like biology and even physics and also science, other sciences and also not only sciences. So it's not excluded for chemistry. And this is the first answer. And if you want to have an escape room in your own course, I think you can do it. And also start small, like Daniel said. Don't create this beautiful escape room like we present. You can create an escape box, for example, that in order to open the lock for the first box, they need to solve something in physics, and then something, and then inside you have another box with a lock. And in order to open this lock, something in engineering, and in this way to cover or to summarize all the concepts you want to summarize in your course or in your lecture. So it doesn't have to be so professional like the ones that I presented, but even, you know, escape box have the very good impact on student motivation, collaboration, teamwork, and creative thinking, and so on. So Malka, do you want to add something, Malka?
I think that we should accelerate because I have messages from the organizers that I should close the session. I'm sorry, Malka, if you can be very fast within a minute, you know, we will appreciate.
It's okay. Ron said very well.
Okay, so in the meantime, I have 1 minute, 2 questions from Nuno to Daniel. How do you monitor students' activity? Which KPIs do you use and how do you measure them? You have 30 seconds, Daniel, for this answer.
The question was asked on chat. I'm going to answer on chat. Ask someone else. I'll address it.
All right, to Manolis then. That is the question that we have. What is the additional effort by the students, Manolis?
The additional effort is that upon every other thing, they had to meet at least 3 or 4 times per week for a time, at least half an hour, to discuss what they have learned, what they have researched, and how to make their PowerPoint presentation.
And they have not passed, no, they have not passed the class yet. They have to give the exams and then we are going to compare what is happening. So I have to close. I mean, I'm not controlling the session. You know, we have the control panel, Yisai is up there and watching me. I would like to thank all the speakers. I would like to thank all the attendees of this session. And we are grateful. And we hope that next year we are going to meet all together face-to-face in Israel and, you know, interact. Okay? So, Toda Rabba is the only word that I know. Salom and bye and be safe. Bye. Thank you.